In this video, you will learn the procedure to calculate some statistical parameters. The most important step in the statistical analysis of waves is the sorting of data. To evaluate the relevant parameters explained, arrange the record values, which is composed by wave height, wave period, and wave direction, in descending order based only on wave height. By doing so, the original record will be different, with highest waves in a descending order but with the associate wave period and direction from original record. By doing so, we can obtain the next parameters. The 1/2 wave height is the average of the highest 50% of waves. The 1/3 or significant wave height is defined as the arithmetic mean of the highest 33% waves. The 1/10 wave height is the average of the highest 10% of waves. The 100th wave height is the average of the highest 1% of waves. The 1000th wave height is the average of the highest 0.1% of waves, and so on. Then it is possible to calculate the statistical parameters related to wave period. The 1/2 wave period is the average of the periods associated with the highest 50% of waves in a record. The 1/3 or significant wave period is the average of the periods associated with the highest 33% of waves in a record. The 1/10th wave period is the average of the periods associated with the highest 10% of waves in a record. The 100th wave period is the average of the periods associated with the highest 1% of waves in a record. The 1000th wave period is the average of the periods associated with the highest 0.1% of waves in a record, and so on. Let's see a simple example to calculate statistical parameters of any given wave record. The record only contains wave heights. Suppose we have collected a wave record from a buoy in the sea over a period of 20 minutes. After processing the data, we obtain the individual wave heights. For this example, the wave heights in meters are showed in the table. Now follow the next steps. Step 1. Sort the wave heights in a descending order. Step 2. Select the highest third of the waves. In this case, we have a total of 10 waves. The highest third of 10 waves corresponds to the top 3 waves. So the total number of waves is 10. The number of waves in the highest third are 10 divided into 3. The result is 3.33. Since there are no fractions of waves, we must apply the rounded rules. So 3.33 is rounded to 3. With this, select the top 3 highest waves from the sorted list. These are 2.0, 1.8, and 1.5. Step 3. Calculate the significant wave height. Calculate the arithmetic mean or average of the heights of the waves in the highest third using the formula. In this example, the significant wave height is equal to 1.77 meters. From the original record, we can also calculate other statistical parameters such as the average of wave heights, the maximum wave height in the record, the minimum wave height of the record. Now let's see a more complex example. The next table contains the original wave record showing wave heights and associated periods measured in some place of the Caribbean Sea. The graph showed corresponds to the time series of wave height and the associate period for every measurement. We are going to calculate the significant wave height and the significant wave period. Then we will calculate the 1/10th wave height and other basic parameters. Let's begin. Step 1. Step 1. Sort the wave heights in a descending order. Once sorting was made, we can estimate statistical parameters according formulas explained before. Step 2. Select the highest third of the waves. In this case, we have a total of 26 waves. The number of waves in the highest third are 26 divided into 3. The result is 8.66. Since there are no fractions of waves, then apply round rules. So 8.66 is rounded to 9. Select the top 9 highest waves from the sorted list. These are marked in the green box and will be used to Step 3. Calculation of the significant wave height and the significant wave period applying the formulas explained before. The first 9 wave heights are included in the formula, and the resulting significant wave is equal to 3.48 meters. Now, to calculate the wave period, we are going to use the 9 values of the associated period. Applying the formula, the significant wave period is equal to 7.94 seconds. Now, for the calculation of the 1/10th wave height, we need to select the highest 10% of the waves. In this case, the number of waves in the highest 10% are 26 divided into 10. The result is 2.6. If we apply the rounding rules n is equal to 3, now select the top 3 highest waves from the sorted list. The first 3 wave heights are included in the formula for the 1/10th wave height, giving a result of 7.08 meters. With all calculations, we count with a basic statistical description of waves or a description of a sea state.